And now I'm going to share my screen. Okay, you guys see my screen now? Okay.
Yep.
I think you can. Okay. Damn.
Yeah.
Okay. So we're gonna script a static website in this course, which is very exciting. And finally, we can put what we have learned into production. And this is sorry. I remember in the version that I sent to you a week ago, there should be a cell. Let me show you. This is not the same. Here. There should be a cell that said we're going to script international weather website, but this is not true. This is from an old version of the keynote. You know, because when I was preparing for this keynote, at first I was I thought about to script the national weather website, but it's far less interesting than scripting this newspaper website. So then I changed my mind and decided to script this website, but I forgot to delete this line, so you can delete it. No. This is our website that we're gonna script, and this is what it looks like. Normally, it should have the photos and stuff, but it doesn't appear here. Okay, cool. This is the website, and if we did it right, we will script all of the contents, all of the articles in this website. So first, let's analyze the URL. So as you can see, HTTP. Sorry. Okay. Oh, by the way, feel free to interrupt me and by asking any questions. I'm not sure if you guys understand every point that I said. So HTTPS and the // we don't have to worry about that. English.lpass.com. This is the main part of the URL. And in most cases, you shouldn't choose that. You shouldn't modify that. But what's behind it, the news / politics, those are, how to say, like the directories, like the folders inside this main site. And for example, if you put in like politics, it's going to direct you to the political section of the newspaper. And let's say Max. Yep. If you want to read the Mexican content, the URL is lpass.com Mexico. Oh, this is the rare case because it's a Mexico. It's a Spanish version, so there is no English dot in front of the main site. Or let's switch back, and I believe there should be other sections in here. Is you know, instead of just politics, maybe economics. I'm not quite sure. I'm not quite familiar with this website either. ESP, Mexican English. Yep, here we are. So let's see the opinion. Yep. Here, the URL is, let me copy paste it to there. The URL is /news /opinion. It's not a politics anymore. So by modifying the URL link, we can visit different websites, and that's quite important. Why? Because that entails pagination, and because let's try it. So this is the first page, right? And let's hit next. As you can see, there is a 1 behind the URL, so this means it's page 1. So in this way, we can loop over this URL by putting 1 to 0, 1, 2, 3, 4, 5 to it automatically and script all of the pages. And we can also script by modifying the section name and script all of the sections, like the opinion sections, economic sections, politics sections, etc. Okay, and we can use a placeholder to define a URL generator. We're going to talk about this in the middle of this course, I guess. But I just want you guys to refresh the definition of placeholder. Do you remember what's placeholder? Placeholder features a .mat code. So it's something like, for example, if you want to loop over the section here, we can say it's URL this one and URL new, call it URL new equals to let's copy paste this URL, this one, and we leave it as a curly bracket and dot format, and let's say section. Okay, so if the section is economics, okay, then this URL new should be https english.ielts.com/news/economics, right? Let's try it. Okay, this is what we got. This is a placeholder. So why do you need a placeholder? That's because you need a loop over. Sometimes you need to do pagination and loop over all of the pages. So you can put the page in here like I or page, and you can do a while loop. Say, oh shit. For I in range, I say 10, script 10 pages. Don't forget the indentation. So in this way, we create 10 URLs, right? With 10 page numbers. Oh, no. Print. Right? Oh, response 200. No, this is not. Right? Okay. That's of course. And so let's start with scripting one item in one page. And we're going to move further to script one whole page and script all of the pages. So to to do web scripting, the most simple package that we need to import is request and beautiful soup inside the BS4. So I don't remember the case when we need to import the whole BS4 package, but I think you can just import the beautiful soup from BS4. You don't need to import the whole package. And this is it. And let's do request.get. So get is not like get URL, tell the code to get an URL. That's not how it works. Get is actually a terminology of, how to say, there are like 6 or 7, as I remember, methods inside the request library, which is like an industry standard. Let me show it to you. HTTP methods. Yep. Here we are. This is a sample of the HTTP methods. So HTTP methods allows you to interact with the website. You can do a get method to query, to request the data from us. The request is so misleading. It's not actually a request, it's actually query or get or download the data. Get is is used to download the data from a website or a server that hosts this website. And post is to send data to the server that hosts this website. Sometimes, sometimes you can just post something and the thing just magically appears in this website, or you need to specify a set of credentials to post your stuff to the website, and that is the most case. And you can put, post, or put, or delete. I believe there are many methods here, and in our case, we're going to use the get method. And in Python, to execute the HTML methods, we use requests library. So we can do request.get, and to download the data from this URL website, from this website, and we can do request.post and put something in the curly in the bracket here to post something onto the server that hosts the website. Sometimes it will appear on the website like immediately, or sometimes you need some credentials to make this thing appear on the website. Use get. Let's try it first. So our URL is this one, right? This is our URL. And let's import the package, get the page. Okay. And let's examine what's inside the page, okay? This is what's inside the page. This is a total mess. So what we're gonna do is to find all of the useful information inside this mess and organize them in a certain way, and put them all inside a table like this. We got the title, the link, the author, place, date, time, when the paper was published, and the description, which is like a short version of the content. We're gonna transfer this mess into this table. Okay, this is what we call the ETL pipeline. ETL pipeline is short for extract, transform, and load. By extracting, we extract useful information from this mess, and by transform, we transform the information into a structured table, structured data source, which is this table. And by load, load is actually a terminology when like a cloud computing terminology. It means we can load the data or save the data to some server or some database, etc. And now we're just going to put it in locally in our computer. Okay. So after we examine the page, that content, let's delete it because it's a total mess. And let's group one item in one page. Okay. So after we import the request, we do request.get. That means we successfully connect to the website, and we get the page, we got the content that we want. Okay. And after we import the beautiful soup from BS4 package, we need to do this line of code. That means to beautiful soup is actually a very powerful package to analyze this total mess. So here we tell beautiful soup to analyze the page.content, this mess, by using an HTML parser. So in this way, we parsed this total mess into a more organized, more prettier kind of thing. Let's try it. It's called soup.com. Okay. Looks much better, right? Well, it's not much better, but actually, but at least not that disorganized. Okay, so let's just don't show it. All right, so now let's go into the website. Let's see how many people are here now. Now let's go to the website and yeah, and examine the source of this website. Okay, so by right click, just basically anywhere, or just right click on the item that you want to script, and select inspect. This is the source code. So if you want to script, let me see. Let's see what I want to script first. The link. So we're gonna script all 5 items. 1, 2, 3. So all 6 items in this web page. Title, link, author, place, date, time, and description. Let's start with the. Let's see. Yeah, let's start with the title. Okay. So these are the title, right? Let's examine the title. What's under the hood for the title for the title. And as we can see here, the title shows in here, right? So how can we extract this information from this website code? I've sent you a crash course of HTML in the documents, in the first document that I sent to you, which is to teach you how to install the environment. But I don't. I'm not sure if you have studied HTML before. So I'm gonna give you a quick going through of what HTML is. So this I don't know how to call it, but this looks like a kind of a bracket. This is called a tag. A is a tag, and href and blah blah blah. These are attributes. Attributes of this tag A. Right. All of the tags and attributes form this whole website. So that's all you need to know about how to script this website. And yeah. And by extracting this information, we can just use soup. As you can see, we have created a variable called soup. Soup contains all of the HTML codes inside this page. So that means we want to find something inside the soup. And this is the tag called h2, and this is a class, which is an attribute. But in this way, we can pull out what's inside this tag and this class attribute. So let's see. Okay, here the tag is A, and the attribute. What the heck? Hold on a sec. I think it changed something. What happens? Alarm of Spanish expires.
Boyan, it's just because you're in the opinion and we are in the politics section.
Oh yeah. Okay,
there you go. Fixed it.
Okay. Politics section. Okay. I think maybe that's it. Now let's just examine this one. Or this one. Okay. Okay, let's see. So how to say, we can, if you want to extract this element, the Spanish government's blah blah blah, you can tell the soup. Where is the soup? Yeah, you can tell the soup to get the A was inside the A tag and this href attribute, but that's not sustainable. Why? Because this rhref attribute, frankly, you know, apparently this is a link to this article. So this link is different for every articles, right? We can't use one link to script all of the contents in this website. So what we can do, we need to find something that is not changing with the articles. So that's this class, this one. As we can see, there is only one element inside this class, right? So we can definitely use this class to stand for this element and tell the soup to extract this item, this title. And the tag of this element is h2, and the attribute is the class blah blah blah. Okay, and in this case, I just say it's h2 tag and class is this one, but this is not right. Why? As you can see, this attribute, the content of this class attribute is exactly the same with what I see here, but this is not the real content. Please remember that that's really important. Let's try to copy this element, copy the outer HTML to somewhere like here, okay? And copy paste this class to here, okay? And delete it. If we find something, because we didn't assign this the result of this code to any variable, right? So when we execute this line of code, it's going to show us the result on the console and the terminal here, like immediately. So let's see. Oh, it finds nothing. How come? We did see that this line of code stands for the title and the link here, but when we want to find it, it gives us nothing. Gives us nothing. Why? Let me show you. So there is there are two things that are called the inner HTML and outer HTML. So the inner HTML is, let me start over. So when you request a website, when you type in the link of this website and hit enter, and after like 3 seconds, you see the content of the website. What happens under the hood? What happens under the hood is when you type in a URL, your web browser actually sends a request, a GET request to the server that hosts this website, and the server gives you a response. The response sometimes, in most cases, the response is a JavaScript script. It's the coding language is called JavaScript, and the script is lots of lines of code. So the server will give you a JavaScript script, and when the script is sent to your terminal, which is your the web browser, your web browser will decode or trigger or execute, whatever you want to call it, the JavaScript, and the JavaScript will give you the whole page. But that is called a dynamic website. We're going to talk about it in the next course. In this course, we're going to talk about a static website. For a static website, the server will give you all of the HTMLs that has the content of this website. It will give you the content directly, but not very directly, because the HTML is slightly different. In the HTML in the server is slightly different than the HTML in your terminal, in your web browser. So these codes are codes in the server, okay? And when you request it to your local environment, like here, this page, when you execute the request.get, this page contains the HTML in your terminal. That's not in server anymore. So this HTML is slightly different than the HTML in the server, which is here. So so that explains why when we want to find a tag and a combination of tag and class like this, it gives us nothing. Okay, and let's call it soup.prettyfy. and so as to make the soup more human readable. I can see this. This is not human readable. Okay. Anyways, so what we want to do here is to find this class, find the real name of this class in our local environment, and put the real name of the class inside this line of code and get what we want. Okay. So, but this is total mess. What we can do, right? We can just find something by looking at, by watching every line in here, right? So what we can do is to do this, is to export these codes into a file, so we can do find and replace in this file, right? Before exporting this file, we need to make sure what's our current working directory by executing os.getcwd, which I have covered in the previous courses. We can see the working directory is this desktop Python course, this folder, and let's export this file, this source file, by using these line of code. I haven't covered these file IO codes in the previous courses, but because I don't think we're going to use it very frequently. In most cases, you only need to remember how to export or import a CSV or XLSX file with pandas package. It's like pandas.read, pandas.write. This is and that is very, very simple and easy to remember. But in some rare cases, you need to write out or read a TXT file. In that way, we need to use 3 lines of code in here. So in the first line of code, we're going to open a virtual file, just a file, which is like we tell the memory, tell the RAM that we're gonna write a file. So you need to get prepared. So we can open a non-existing file called source.txt, and W means write. So that means we want to write something into this non-existent file. And in the second line of code, we call file1.write source. The source is the variable in here. So that means we want to write what's inside this variable to this file. Okay, and we close it. In this way, we should have a source.txt inside this directory, this Python course folder. Let's try it. Okay, to succeed, let's open our folder and data modified. Okay, here, this is our source, and we can do we can find every element inside it. But there is a better way to open this source, which is in the VS Code here. Okay. So in this way, we opened the source inside our editor, which is the VS Code, and we can split it to 2 screens. Hold on. Here, right? So in this way, we get a like HTML version of the website, and we can look up every element that I want to see, want to find. Okay. So in this way, so as we remember, this class doesn't work. The name of this class attribute doesn't work. Okay. So let's try if we can find some similar class name. Let's try this one. Find something inside it. No, it's not, right? Oh, it's a headline, right? So headline must mean some something with the title, right? Oh, here we are. H2, right? We have the H2 here and class, blah, 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 color gray, ultra, dark, front, secondary, blah, 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 blah. Yep, that looks exactly like this. Kind of like the same, but what's different? The difference, there is no space behind the MD, right? No space. And there's only 1 space between the full and headline, but there is 2 spaces here. Yeah, that's That's the difference, and that's what makes us can't return, can't get the content inside this combination. So let's copy this class name and paste it here. Yep, we got what we want here. This is what we want. Okay, and let's move to the next section. Okay. Yep, here. So in this way, we got what we want here. And but how do we just get these elements and get rid of all of the other noises? Okay. We can just do dot. What's inside? We can just do put dot text behind it. That's very simple. And why by doing dot text we can get what we want? And let's go back to the HTML file. Okay. So as you can see, the A is a tag and a href or class is an attribute. But what's this? These words and what's the name of these words? They are actually the content of this combination. So as you can see, there is a you can figure them out by judging the colors of this element. So this element is kind of white, and it's not like the other items of this section. The H2 is in blue, and the CH headline stuff, the attribute is in green, is an orange, but these elements are in white. They're not colored. So these are the contents of this combination, and we can just pull them out by call dot text. And we get what we want. But this, if we just add dot text behind it, the code is going to be too long, and that is not a best practice. So we assign it to title, a variable called title, and let's do title.text in this way. We get what we want, which is the title here. Okay, so this is the first step. And next, let's find out the link. Which is very simple because the link is nested inside this H2 CH headline combination. Okay, and we can just find something inside this title, which is here. This is not a title, actually. The name is a little bit misleading. This line of code stands for these mess, okay? And inside this chunk of words, we have the link inside it and the title, okay? So by calling that text, we got the title. By calling that text, we got the title. And we can find the link inside this chunk of words. And what can we find? We need to find a tag named A and the issue and the content of this href attribute, right? This is an attribute. This is not the Spanish government resist anymore, because it's first of all, it's colored in gray, and secondly, it's the content of some variable which is called href, but it's not called a variable in HTML. It's called an attribute. So by pulling out the content of the attribute, we don't just by calling .text, we do .get. Okay. First, let's find an A tag inside these things, which is the href, right? And let's get the content of the href, which is the link. And let's call the link, right? We got what we want. But this is not the link. You know what's missing on the link? The main URL. So we can just assign this main URL into a variable called base and concat them together. We can just, concat them together, and we get the real link, which is here. This is the real link. So when we copy this link and paste it somewhere, we get the article here. So in this way, we have how to say, a key or a door to the articles. Okay, and we can script every item inside the articles. But we're not gonna do it because if we're gonna to script what's inside the link, this entails another level of data cleaning or data pipelining. We're gonna cover it in the next course. Today, we only script the content inside this main page. We're not gonna go deeper into the sum page. Okay, and let's find the sideline here. This is the sideline. Oh, what's the sideline? Sorry. No, this is the sideline. So what's inside the sideline? The author, right? And the place where it's published, and the daytime. As expected. Okay. Okay. So oh, here is the author. We find the author, and okay, this is the second author. What's the place? Yep, this is the place, and the daytime. Yep, we find the daytime. The daytime is actually the content of a daytime attribute. Okay, so we find the 4 elements, but we need to find out how to pull out these 4 elements. So we need to find the father structure. Let's see. All right, I think this is the father structure. Yep. By the way, can you guys see my screen? If it's too small, I can just zoom in.
I can see it.
Cool. Okay, so I think we can just get all of these 4 items by pulling out whatever inside this div and class CB byline, blah, blah, blah. Okay, so let's do it. Let's first find a container called slide line, and we'll find the div and the class like this. But we can't just copy paste this class name inside our code because it's not correct. This is the HTML code on the server, but we need to find out the HTML code in our computer, okay? So we can just search CB byline here, CB byline, right? Here, and I copy the sign-up code in here. And we got a sideline here. So let's see what's inside the sideline. All right. These are in the sideline. And we can find the author here and the place where it's get published and the daytime. Everything is inside here. And the author is where is in the author? Where's the author? The author is actually the author is receipt. Sorry, let's examine this one. Okay. The author resides inside this A and href stuff. Okay, but as I've said, we can't use the HTML to get the author because the HTML changes with the articles. So we need to find something that doesn't change, which is this span class false. Okay. Okay. What's inside the span class false? Only one stuff, which is the the author. Okay, so that's perfect. But as you can see, we can't just copy paste this space false here because in our computer it doesn't have the space, and yeah. So right, this is the author. We get the author here, right? Carlos E. Q. And the place, where's the place? Let's examine the next element. All right, the place is here. Okay, so as you can see, the class is capitalized. This capitalized doesn't change with the articles, so we can confidently to by calling this the span tag and the capitalized class to find out the Madrid element. And as you can see, the Madrid element is in white, and there is no like class or tag around it. So we can just I can just pull it out by calling that text behind this container. Okay, here we got the Madrid. And so while we can only put in class equal to capitalize inside the find function, you know, as you might remember, we need to specify the tag as well as the attribute to pull out what we want. Okay, but how come we can only pull out the content by calling by putting class attribute in it, but not the tag? Here's why. Yeah, because the sightline. Do you know what's the sightline? This is the sightline. We have already put out the chunk of codes that we want to that the content resides. So we don't need to call the tag, because by calling the class, where we have enough information to get rid of all of the noise and only keep the Madrid here. So you know, of course we can put span in it and we get the same thing here, but we don't need to. Class is enough. And let's find out the datetime. What's the datetime? Yeah, this is the datetime. And as you can see, the datetime is actually the content of the attribute, of datetime attribute. So we can't do that text anymore. We need to use that get. Okay. And let's find the tag named time. And we're in this line of code. And get the content of datetime. And we got this one. As you can see, this doesn't look like what's on the web page. Okay. This one and this one, they don't look the same. Why? Because this one is actually a special a datetime object. You know, you can format your datetime into something like this, and to make the machine, so this datetime is more machine readable, and this kind of datetime is more human readable. But you just can't let the machine to read this type of datetime, because the machine got confused, and the machine only knows how to express how to understand the datetime like this. Okay. And the description. This is the description. Let's inspect it. Okay, here. Oh, we got it. So how do we pull out these items? We can just do it by calling the p tag p and the class cd description blah blah blah. Okay. As usual, let's search for cd space description in our local environment. All right, got it. And copy paste it here. And don't forget to put that text behind it. And in this way, we get the description. So now we have all of the 6 elements for the first article in this website. Now we're going to move forward and get the 6 elements, all of the 6 elements for all of the articles inside this first page, all of the articles. How do we do it? As we find, when we want to find out this element, we use soup.find. Okay, that only gives us the first element that it finds out that meets this criteria. But there is a function called soup.findAll. Find out gives us all of the elements that meets this criteria. So let's try it. Okay. What the heck? Yep, we got this. Forget this line. Sorry. Let's do it actually. Soup and let's see. So that gives us a list actually. Let's examine the type of this variable title soup. Okay. It's a result set. Oh, okay, but actually it's actually a list because we can slice it. You know, let's find out. Okay, let's see the length of this list. Okay, 27. So we have 27 results, 27 articles that meets this criteria. Okay, we have 27 titles. As you can see, tight line here. And what's the first element? This is the first element. This one looks exactly the same when we call soup.find and blah, blah, blah. Remember? Here. They look exactly the same. But in this way, we have all of the titles, not only the first one. And here we're going to do something called list comprehension. I believe I've covered in the second session, but unfortunately, the recording didn't go well, and I only recorded the later half of the course. So I'm gonna go. I'm gonna teach you how to do list comprehension again. So the list comprehension is to transform each element inside this title soup list. It means to get the dot text. It's not get to call dot text for each element inside this title dot soup, and we got a new list. So I believe you remember how to pull out this real title to add dot text to it next to it. Okay, right? But how do we call dot text for every element to every element of this 27 of this list that has 27 elements in it? List comprehension. So how do you do a list comprehension by yourself? First, let's put a square bracket, and as you remember, the square bracket is a symbol for a list. And you can just say everything like item or something. Doesn't matter. First, you need to put in what do you want to do for each item inside the list. Here, I want to do dot text for the item, for each item, and put in for item in the name of the old list. And this is gonna be a new list for you, which we call title list. And when we call the first element of the title list, it gives us the real list with the first element. We can examine the second element here. Okay, this is the second element. Spanish government resists pressure, blah blah blah. right? Spanish government resists pressure. So list comprehension is like a simple version of a for loop. You can, if you don't want to use this one line of code, you want to make it more complex, more less human readable, you can just do for I or for item, whatever, for item in title soup, loop over each item inside the link, and oh, you need to do a title. Let's call it title list 2, okay? It goes to a blank list and then loop over every item in the title soup. Oh my shit. Title soup object, and do let's append each item to the, sorry, what do you want to do to each item? I want to call .text, right? But you need to put each item inside the empty list. So I can do it by typing this line of code, list to .append, and put it inside the append function. Here we are. Right? One. We got the same element here, right? So what the fuck? Well, it doesn't matter. So this line of code, list comprehension, is equal to the 3 lines of code in here. Okay. And yeah, in this way we have the title, the 27 titles. And oh, by the way, when you want to script something, it's the best practice to examine the length of the list first, because in some cases you might find out, for example, if you forget to find the real HTML in the local environment, let's say if you accidentally put a space behind it, it will return an empty list. Let's try it. Yep, the length of the list is 0, so that means you failed. Okay, you got nothing. And so this is the time you need to examine what went wrong and execute the line code again. You got 27 items here. That means you succeed, sorry. Okay, so this is for the title. And next, let's move on to the links. What we're doing here is to copy this variable and assign it to a new variable. Why do we just say link.soup equal to title underscore soup? Why do we just do this? Why do we put a .copy behind it? This is because in Python and in most other coding languages, equal, sometimes equal does not only mean one direction. Sometimes it's like both directions. The two variables affect each other. So if you don't want to the newly created variable, any modification to the newly created variable to affect the old variable, you need to do .copy behind it. And in this way, there are two totally separate elements, totally separate variables. Okay, so in this way, you get the link underscore soup. Why do we do this? Because as you might remember, the link and the title is in the same section. Okay, it's in the same section. So the soup is the same. And so we get the link soup, and let's find out, let's do a more complex list comprehension. Okay. How do we pull out the link inside each each element inside the link soup? See by pulling out what's behind the tag A and get the content of the href attribute, right? So okay, so find for each element inside the link soup, we find A and get href and concatenate with the base URL. This is exactly the same as we did before to the link here. Okay. But here in this section, we do it in a like list comprehension fashion. And this way we got the link list. And the length is correct. And let's examine the first element inside the list. Okay. Right. Correct. This is the link to the first document. This is the link to the second document. Let's see if it's correct. Oh. Okay, Spanish government resists pressure, blah, blah, blah. Spanish government resists pressure, the same. And let's find out the sightline, which contains the author, the place, and the datetime. Find all. This is the same as what we did before, except the function is find all instead of find. And let's do a list comprehension for each element inside the sightline soup, which is to find the class false. And this is all the same with the thing in the first section. Examine the length of the author and the no. Mm-hmm. Oh yeah. Okay. Length of the author. And let's examine the first element of the author list, Carlos EQ. This is the author of the first article here, Carlos EQ. And let's find out pull out every element of the place. Okay. Inspect. The place. Okay. Put here San Sebastian, and this is a span and capitalized class. Okay. Yep. Let's pull out all of the playlists in here, but it says non-type object has no attribute text. What does that mean? That means there is an element. There's an element inside the sightline soup that doesn't have that returns nothing when we want to find a class named capitalized. So nothing. This is nothing. So we can't just pull out text from nothing, from non-type. Okay. In this way, we should allow this kind of error when we script the website. Actually, the list comprehension is not the best practice, but it's the most convenient practice. So so that's the reason why we need to check the length and the elements inside the list comprehension app each time we do the list comprehension. And so as in here, some of the articles doesn't have a place. Okay, and I don't remember which article, but there is some articles which don't have the place here. I don't think I think this one doesn't have a place. Okay, so it finds nothing. How do we avoid this kind of problem? We do the old-fashioned way. Okay, and we add in a try except here. So let's start with an empty list which we call place list, and for each element inside that sightline soup is a container for all of the place, time, and art authors. For each element inside the sightline soup, let's first try call the find.find class capitalize.text. Okay, if this line of code fails, if it gives us a non-type error, give us an attribute error, which is called the non-type object has no attribute text. So as you can see, except attribute error, that means if it gives us an attribute error, we we'll give an empty string to the variable called place, and we append this place as each element inside the place list. Okay. So in this way, if we encounter some articles that don't have the author or place or date time in it, we don't have to break the loop. We can jump over the loop and assign an empty value to this element. Okay. Let's see what's inside the list. Okay. So you can see there is actually one article that doesn't have the place where it got published. Oh, two articles actually. This is a very important technique when you want to script something in a steady and secure fashion, because if you still remember the final goal of this course, which is to build an unattended web crawler system on AWS. Okay, so by saying unattended, we want something to run like anonymously or automatically just in there, and let's do something else. Let's read a book or watch a movie, and after maybe 2 hours, or we just leave it there, and maybe after 1 year when we come back, it gives all of the things that we want to see. We don't want it to break at some point, like also automatically and without us knowing it. So we need to add in some fail-proof mechanisms inside the loops. This is the datetime list. First, let's try list comprehension. Right, we get them all. So in this way, I think I can assume that each element should have a datetime and author, but not the place. Length is 27, correct. And description, the codes are all the same. Description, length of description is correct. Okay, so we get all 6 lists here, right? The first list is title list, and the second is link list, and the third is author list, and we have place list here, place list, and the datetime list, description list. So we have 6 lists of the same length, which is 27. How do we put the list into a data frame, a table? Data frame is just a fancy name in Python. That is equal to table. How do we put them there? I think we can do something like this. Hold on a second. Something like this. This is the title. Let's call it T. Okay, equals to blah, 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 dot, blah, 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 dot, blah, blah, blah. And there are 27 items in it. Okay. And we have the link list. All the lists. There are 6 lists in here, right? And the last list, as I believe, should be the description list. How do we, and they're all of the same length, how do we put them together into a table? We can just pivot them to something like this. T and L and the blah blah D. Okay, and these should be the headers, and these are the contents. Okay, but how do we tell Python to finish this task for us without, to run the code? Yeah, in a simple manner. Fortunately, Pandas, the package Pandas, built this function for us. Let's import pandas as PD, and let's create an empty data frame by calling PD.dataframe, and we tell what's the column name of this data frame. The column name is title, link, author, place, date, time, and description. We don't want to just use the name of the variable because it's not like very user friendly. Description list. What's a description list? It tells us nothing. So we just put description as the name of the column. We have 6 columns here, right? And this is the empty data frame. If you don't believe it, let's call it empty, all 6 columns. Then let's say the df.title, this means by calling df.title, it gives us all of the contents of the title column. And we put this list into this title column. Okay. And we do the same for all of the columns. Bang. We get the df, get the data frame. This is all of the elements inside the first page.
But one question, is there a way to export that to Excel?
Definitely. Oh, this is a huge bummer. I talk about that in detail in the second course, but I didn't record it. Oh, damn. The Zoom just broke down in the last time. Okay, so df is the table, right? There's a built-in function called toCSV inside the pandas package. We can just say the name of the df, name of the data frame dot toCSV, all in lower cases, and put in the name of the file as the first element, first parameters of the toCSV function. Let's call it a one page, okay, .csv, and comma. In most cases, we don't want this one as a separate. Oh, forget it. Let's just try it. Okay. First, we need to examine the current working directory. Get cwd. Still the Python course, and let's export it. Succeed. One page. Right. What's wrong? We've got this separate column here. We don't want this column actually. So what we're going to do is to put a second parameter behind the first one, which is index equal to false. Override the old file. Open it. All right, it's gone. This looks like exactly like the what we see in the Python file. There are some words that is not right, but I believe these the reason that these words are not right is the encoding problem. As you know, there are lots of encoding methods out there. The most popular one should be the ACE. I don't know how to call it. Let's see, ACE. Yeah, this is the most ASCII is the most popular encoding methods for Latin words, which includes the English words. For other kind of characters like the Arabic or Chinese or Japanese, they use UTF-8. So sometimes if you want to convert, how to say, if you're in a coding environment which is dominated by the ASCII encoding method, all of the other characters which doesn't support the ASCII, for example, the Japanese, Chinese, or Arabic, they're going to be a total mess, like something unhuman readable. So you need to do like encoding and decoding with UTF-8. Here, I believe there might be some encoding problem, but that's a minor issue. So in this way, you got all of the contents in a CSV.
Thank you. And yeah, I think it's the accents. It looks like the Spanish accents.
Yeah, maybe. And you can also export them as SLSX to Excel and .xlsx. And we got the Excel here. In the Excel, we have a much richer format here. We have the actual link, which we can click, and okay, damn. Okay. And I introduced a more portable or more lightweight way to store the objects or the tables. You know, sometimes how to say, sometimes as I've said, there are some encoding or decoding problems with the characters. Okay, so let's say if all the characters are in Spanish or say in Chinese, okay, and we export them to .csv and we open it, it's all a total mess. All of the weird symbols there. And so when we open it, it's still all the weird symbols. It doesn't have the proper encoding and decoding. So in that way, we lost some kind of information. We just lost the information because of the format issue. So how can we just avoid the format issue? We can just export them to a unified kind of file called feather. Let's import feather. Yep. I believe you have installed the Python. I installed this feather package for the course because I've particularly mentioned the feather package in the instructions that I sent you before the first course. And I can do df to, you can see, you can do lots of different formats here. To clipboard, you can put them, you can output them to your clipboard. To CSV, to dict, to feather, to CM, to JSON, LaTeX, SQL. Oh, I can output them to a Stata file, actually. Here we're going to use to feather. One page.fed. that feather or something? I kind of forgot. Sorry. Let me search into Google. Feather file format. Yep, that feather. That feather. Okay. This is the file. And one more advantage of this feather file is it takes up much less space in your disk. Here we can actually see that there is a huge difference between these two type of files in terms of the size. But if we have a very huge file which takes up maybe 2 megabytes for the CSV file, and the feather should only take like several KB, like 20 or 30 KB. So that's a huge difference. And but the disadvantage is that you can only read the feather file with Python or other coding language. You can just click open it. You can't click open it. Okay. By the way, this is a state-of-art technique in the in the programming industry. Okay, let's move on. Oh, by the way, do you guys need a break? Like we can take a 5-minute break.
Sure.
Okay, so let's take a 5-minute break and come back at 10:23, 10:24. Okay.
I'm going to have to leave a little bit early today, but thank you for the lesson.
Cool. You can check the video or the keynotes after the course.
Sounds good.
Mm-hmm.
Take care.
Yeah. Mm-hmm. All right. Let's start. Okay, so now we can make it better by grouping all of the pages, not only one page. As you can see here, we can import the request file, request package, and BS4, a beautiful soup from BS4 and the panels. This is the whole package, whole set of the packages. And let's define a URL generator. If you still remember how to define a function. So let's say URL is, let's use a placeholder that we have talked about in the beginning of this course. Placeholder. So placeholder is something looks like dot format here. URL equals to this placeholder dot format page and return URL. So in this way, we have different the different pages of this political section. So let's try it. URL generator 1. We got the first page of this this section of the newspaper, and let's say 5. How about let's try it? Yep, this is the 5th page. So there's one issue, because in the first page, in the main page, there's nothing behind the politics /. Okay, this is because this is the first page, and what's the second page? What's it like the second page? The second page is something /1 /. Okay, so how do we, if we loop this over, from 0 like to 10, from 0 page to page 0 to page 10, is it going to work for a URL like something blah 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 /0? Okay, because when we put 0 to the page URL generator is going to give us a something like this, politics /0. So let's try it. Yep, it's correct. This is the main page. They are hold on a sec. They are the same. Great. So let's start with the page. So we can call it a page generator or URL generator, whatever you want. This is a module, and let's start with scripting each element inside one page. So let's call page equals to request.url, and so we connect our local environment to the server that hosts this website. And next, we parse the content of this page by using an HTML parser inside the beautiful soup object, and we get a soup. This is the steps that every scripter should have. So keep in mind. And let's initiate an empty data frame with a title of link, a title with the columns of link, a title, link, author, place, and datetime and description. And next, we need to define a huge function here. So let's break it down to little pieces. First, let's find out the soup, title soup. So the title soup has the link as well as the title in it, right? First of all, let's find all of the elements, all of the H2 and the blah, blah, blah class, CCH headline class elements. And this should give us a list. And let's find out the list, find out the title inside the title soup. And that is the .text for each element in the title soup. All of these has been covered. All of these has been covered in the second section. this section, I think. So let me just go over them for you again. And we have the link soup. Let's just copy the title soup without, in this way we can avoid affecting the older variable by modifying the newer variable. We have the link soup, and we extract the links inside the link soup, although the link soup is exactly the same as the title soup. And so we concact the base element. Oh, we need to define the base element. We have already defined the base element, but this is, we want to create something brand new here, create something complete. So we need to define the base element again to make it complete. Where to define it? Let's see. Go to. Okay, that will do the work. So by the way, this is a necessary step if you want to transform or put something in the lab environment to production. So if this line of code successfully put out what we want in the end, every time we want to script something, we don't have to type in all of this line of code again. We just need to, we can just call processor, just type in processor, and we will have all of the results that we want. And we can delete all of the codes. Sorry, all of the codes before line 191. So now we have the title list and link list, and we can pull out the author list and the playlist just as the title and the link list by finding the tags and the class inside the HTML codes. And for the place list, if I remember what I talked about in the first part of this session, we need to add in an anti-file proof mechanism inside the loop. Oh, by the way, you don't have to specify the type of the error each time. So, for example, if you say you want to avoid all of the errors, all type of errors, when you loop over the side line soup, you can just say except nothing. So in this way, by deleting by specifying the type of error, you can only avoid this type of error. But if you encounter some like connection error, the loop will break. So why don't we want to avoid all of the errors but only one type of error? This is because it's not in a real production scenario. In a real production scenario, we want to in a real production scenario, we want to avoid all of the errors. But in here, this is like a like alpha stage of the production error where we want to find out, we want to try it in the production scenario and find out if there is any hidden errors that happens under the hood. So when we find out there is a connection error, the loop is going to break. And when we look at the logs behind the line of codes, we will find out there is a connection error. And so we know there's a connection error, and we go to the server and go to like the backend machines and find out why the connection error happens. And we solve the problem so the connection error never happens again. But if you only say accept and don't specify the error type, it will never find out the connection error. Okay, until you find out all of the places is empty, and you must think, oh, this is because all of the places inside the newspaper website is empty. They don't have place anymore. That's not true. Okay, that's very, very misleading, and covers the real reason of this issue. So you need to specify the error type. And we have the datetime list and the soup, the description list, and we just put the list into the data frame and return the data frame. So by calling the processor, we have the data frame of this single page, okay, of the single page. Why is it single page? Because we only requested one page, one URL, okay. Indentation, global df, am I correct? There is an indented block. What the heck's going on? Sorry, give me a few minutes. There is an indented block here. I don't know why it gives us an error like this. Okay, let's just ignore it. And now I can actually.
When I copy and pasted it from your HTML, it worked.
Yeah, yeah, it worked right now. Okay. Okay, so in this way, we define a function called processor, and but we're not gonna use it like immediately, because we're gonna put it inside a loop over all of the pages. We can call it a processing unit. And here, oh, by the way, why do we say global df? There's a concept that I want to introduce to you guys. So there are two kinds of variables, the local variable and the global variable. The local variable is a variable that only exists inside a function. So, and the local variable is a variable that exists in the whole coding environment. So I'll say you specified a df, right? A df outside of the function. So df here is a global variable. Df is a global variable. And when you want to use this global variable, you want to read the content of this global variable, you don't have to say global df, because it's globally readable. So you're going to just read it inside your data frame, something blah, blah, blah. And but if you want to modify this global variable, you must declare this variable is global. it must be declared. You must declare this global variable before you modify it. That is the rule of Python. Okay, and yeah, and return the df. So where do we modify the variable here? We put in the lists inside the columns of this df variable. And oh, by the way, let's say if you don't return the df, how to say? When I started to learn Python, there's some weird thing happened. But yeah, for example, on a df, define a function x, and let's say result equals to x plus 1. Okay. So we can expect the when we put in 1, it's going to give us 2, right? But it doesn't work like that. Function 1 gives us nothing. It gives us nothing. Or let's see, the result has we create a variable called result inside the function, and we assign a variable to the result, right? So when we execute this thing and call the function 1, we should have the result, should the variable named result, right? But when we see the result, gives us nothing, and it said name result is not defined. Why? When I first learned Python, I find this really troublesome. This is because the result is a local variable. And when we call it globally, it shows it doesn't exist because the result only exists inside the function. So how do we pull the result, the local variable out as a global variable? The first method is to declare it as a global variable. Then I call it, and result is 2. Okay. And the second method is to return it. Return this variable. In this way, it will convert this variable next to the return code and make it global. Give us 2, okay? So 2. So that is a pitfall of defining and calling functions. And now let's define an empty data frame called df total. So why do we do df total? Because we want to concatenate, we want to put the data frame of each page to the big total data frame. Okay. In this processing unit, we have the data frame for one page, and in the loop over each pages of the website, we put the single data frame to this big data frame. Okay. And let's try it for 3 pages. Okay. For page number in range 3, again, you can see everything other than page number. You can see item or item. It doesn't matter. But to make it more human readable, I decided to name it as page num. So here we're going to use URL generator. Okay. Let's recall what's a URL generator here. When we input the page number, it will return a global variable that is the URL with the page number behind it. And this way, we have the keys to each pages. The URL generator. Okay. So let's say now we're in the first loop and the page number is 0. Always remember the range function gives us a list of the numbers that starts from 0. So range 3 means 0, 1, 2. Okay. If you don't believe it, you can just try it. You can just try it. So for I in range 3, print I 0, 1, 2. Okay. The page, we have the page equals to request page soup. You can just put them like in everywhere that you want to script, where you want to script a website. First connect to the page, and then to parse the page with beautiful soup, and then we call the processor. Okay. This is something we define here. So you know, here we can actually see the advantage of defining a function rather than just calling just typing all of the codes. If we don't define the processor here, we're going to put in all of the things here, and it's going to be a nested loop. You know, why is a nested loop? Because there is a loop inside this processor. And actually, there are lots of loops. You know, the list comprehension is actually a loop, but we just make a short version of it. And this is a loop too. So a loop inside a loop. Sometimes 2 levels of nested loop is fine, and we can understand it like a little bit harder than usual. But if you put like 5 or 6 nested loops inside it, it's gonna be kind of difficult for you to read it. So the best practice is to define a function and call the function inside a loop. Okay. And let's call the function processor. So this processor processes the first page of this URL and gives us the data frame, which contains all of the elements, all of the 6 elements inside the first page, and put this small df into the big df, append. Append is a method that is obviously common to lots of kinds of variables. For example, list. As you remember, we put a list here. We use append to put an element inside a list. We can also use append to put a small df to a larger df. And okay, so I think that's it. Name df total is not even, oh, I need to define it first. Let's script 3 pages, okay? Let's just script 2 pages to save the time. Trigger it. Okay. 3, it takes 3.7 seconds, and let's see what's inside the total, df total, the big data frame. Oh, as you can see, for the first page, we have 27 of them. From 0 to 26, 27 of them. And for the second page, we have 27 items as well. But the index is kind of not right? Because it goes to 26 and starts with 0 again. So how do we do it? We do reset index and drop equals to true. And the list is correct right now. 26, 27, 28, and 53. So now we have 54 articles here, and that's 2 pages long. So do you guys have any questions so far? Like how to define a function and what's inside the loop? Okay.
Now we're following.
Okay, cool. Great. So let's try like maybe 5 pages. It's going to take us up a little bit longer. Yeah, 90 seconds. 189 rows. So we have 189 articles inside this website. Okay, and that's 6 pages long. So in this way, maybe we can just loop over like 100 or maybe 1,000 pages. And we should have, suppose there is 27 articles in one page, 1,000 page should give us a 27,000 articles. That's simple. Okay, so that means this is really powerful in the production scenario. And but that's only because this website is so easy to script. And that is called a static website. I think I should tell you what's the difference between the static website and dynamic website at this point. So let me just show you some evidence first. How much percentage is the static sites? Sorry, I don't remember where it mentions it, but I do believe I've seen it before that I've seen it several years ago actually, only 70% of the websites are, only 30% of the websites are static websites. So that means basically, and I believe this number goes down with time goes by. So now I believe maybe there are only like 20% of the websites are written in the static format. So what I've taught you in this session, it's like a traditional web scraping course, and you just can't use it in the production environment. But this is a good thing because you need to always start with the simplest concept and to further it and to develop it to a more complex one. Okay, and in the next session, we're going to teach you how to script a dynamic website and using Selenium package. So anybody can answer me what's the difference between the static website and dynamic website? I believe I mentioned it somewhere in this session. It's something about what kind of thing the server of the website returns when we make a GET request. Okay.
Well, I guess I can try. I'll say that static site gives all the HTML codes at once, whereas the dynamic somehow in portions.
Yeah, yeah, that's definitely correct. Dynamic websites gives us scripts, give us the JavaScript scripts. JavaScript scripts. Yep. So let's see. Let's try. If we want to script something like Facebook. Oh, Facebook is like maybe the hardest website to script. Oh, I need login. I haven't logged in Facebook like a million years. How about this one? Help. First, let's examine the element inside this thing. Yep, we can see all of the HTML codes here, and then we can extract the elements. For example, how can we help you? We can just say like beautiful soup dot find all and span and put in the attribute, which is this class, and dot text. We get the element here. But if we try to do something like, well, just say URL test equal to this website and let's do a page dot request get URL test. Okay, response. I'll need to find the content. Let's try. How can we help you? Oh, actually, this is actually a static website, I think. Let's see about web. How about this one? Yep. Let's see. This is definitely a dynamic website. Yeah. And one major difference between dynamic and a static website is that there are various elements inside it, inside the dynamic website. There are short videos or GIFs, where the pictures and stuff, links, hyperlinks, icons. So let's examine the elements first. Facebook is here, okay? And how about the picture? This is a link to the picture. Let's try to click it. Click on it. Damn, what's happening? Hmm? No, this is not the thing. Okay, it doesn't matter. I just want to show you this is a dynamic website. And okay. Let's see, URL is this one. URL test. Okay, this one. Yeah, and you can see the URL here is a much more complex one than the URL that we script before. Okay, first of all, it's not very human readable, and secondly, it's written in how to say, in a like something like a secret password something. Yeah. See, this is our URL test, and let's request it and call a content behind it. Oh yeah. Let's speak English. What's that? Oh no. Text. See? This doesn't give us many things in here. Oh, I don't want to do it. Well, as you can see, lots of codes in there. This might not be a very good example. I will give you a good example in the next session, but you can see the HTML here, but this HTML doesn't give you much useful information because some of them are hidden, because you can see the HTML equals in this section href equals to manifest.json. This is definitely a JavaScript code. You need to render this one to get the HTML under, which is under the manifest.json. .json is actually a kind of file format which is similar to the dictionary that contains the value key value pairs inside it, and that is used to store the contents of the websites. Okay, let's get rid of it. Yes, in some most extreme cases, I believe, when you request the page of the content of the page, it just give you a one line of code, which is like something.json, and you can do nothing with it using Beautiful Soup. because it doesn't show us anything. So how do we do it? We need to render the JavaScript first before we dive into and to pull out every element of the HTML. I will cover that in the next session. So this is, oh, we finished earlier than before, than expected. Okay, so why don't we make it more interesting? And
one question. Can I ask you a question?
okay, sure.
So I'm following what you've done here. Wanted to get a big picture set up here. So it looks like what we just did here. You went out to the internet, grab a website, and dump the information inside of it into a setup here that you can transfer to an Excel sheet or whatever. So I'm assuming that there is some utility to this activity, and you could, if you were looking for actual numbers, and you could probably do the same thing, assuming that such numbers existed in a website. Now, my basic question is, the deployment of this tool. Does it have to be deployed where you have it right here, or how is it typically deployed if you have a tool like that?
That's a good question. Actually, we're going to talk about that question further in our last course. The deployment is always the key issue, the key point in the production environment. And here, because this is only a very simple case, and this is not actually a tool. This is well, you can call it a tool. It's homemade, very simple, rudimental tool. We just use Python. Python is an open source coding language. Everybody can use Python, and everybody can use this code. Actually, you can just copy paste the code in your computer, and you will get the same result here. But in a production environment, especially when you wanna, when it entails lots of traffic, because in a production environment, you don't wanna script like spend 19 seconds for 5 pages. That's kind of intolerable in a production, in certain production environment, but in some production environments, it needs it needs the speed to be slower than usual. Yeah, but so in the production scenario, there might be like maybe 100 scripters running at the same time, and each of them scripts like 1,000 pages in 5 seconds. So how do we do that? We need to deploy them in a very special and expensive, of course, environment. And in most cases, that will be AWS, a cloud environment. So I remember maybe several years ago, maybe 10 years ago or something, people still use the servers, use the physical servers for, for example, if let's say we, how many people in here? 4 of us plan to start a tech company called Google, and we need a space to store all of the user data, and we need some computer to run our scripts to process data and send it back our process results back to the users. So we need 2 computers here. One computer is to store the data, and one computer is to compute all of the data. We just buy 2 computers and run the computers, keep it running. We don't shut it down. That's very dangerous. Why? Because it's a physical thing, and there might be earthquake, might be all kinds of damages and fire and like the flood or something. And once that happens, your very fragile server will shut down, and all of the data will be lost. So in this way, in modern times, like right now, we just use the web server. You know, lots of companies like Amazon or Google or Microsoft, they have their public cloud services. You know, AWS has Amazon has AWS, Amazon Web Services, and Google has Google Cloud. Microsoft has Azure, which is widely accepted by the government agencies. So they have the more advanced, how to say, they have their unique advantages to maintain the physical devices. So they just have lots of computers, lots of servers out there, and they rent them out for us, and so that we don't have to worry about the physical condition of the machines. And yeah, so that's how we deploy them in a production scenario. And for these very simple codes, you can just deploy them everywhere. Yeah. Does that
Okay.
answer to your questions?
Yeah. Thank you.
Cool. And in the last course, we will design a very fancy, like a software, something like a software, and we deploy it onto AWS and keep it running, so that we don't have to worry about it. And maybe after an hour, we'll come back and examine the results. It'll give us very rich results on the cloud. We can download it. We can do whatever we want with it. So theoretically, we can keep it running until AWS goes bankruptcy, but I don't believe that's going to happen very soon. So you know, theoretically, I can keep it running like internally. And so it's the program should be a little bit complicated than you have ever seen, I believe. So we may need a flowchart to demonstrate all of it. Something like this. This is the flowchart for my company. This is very simple, but for each unit inside it, we might need like 10 or 20 lines of code. So that's a huge thing. Yep. And so as you may notice, there is a major, okay, so here comes the bonus part. As you may notice, what we really want is the content of the article, right? But we didn't script the content of the article. We only, the most detailed thing is the description, but sometimes the description just tells us nothing. So how do we script the content of the articles? Let's see. Oh, this is, here we go. Okay, politics. The content of the articles is nested inside this URL, this inner URL that we have put in here. So what we need to do is to click open this link and script click open this link and script what's inside this page. Okay. But not the ads and the pictures and stuff, only the words. Actually, we don't need to click open it actually, but we need to get all of the links of the URL, so we can do a second get request for each of the articles. Okay, we have done one request, a get request here, right? Which is the this one. So we only requested several pages of this websites, but we didn't go into didn't request the content of each articles. Now we're going to do it. Okay. So for okay, here let's go over what you guys have lost in the second session. Let's convert. So we have df total, right? Df total. Oh no. Okay, and div total. 190 elements. How do we pull out the link as a list? Yeah, definitely. We have the linked list as a like intermediate product when we generate the data frame inside the function. But actually, we haven't make them global. We haven't make the title list, linked list global, so we can't pull out the linked list just by calling it. Okay. So how do we pull out the link list out of the data frame? We do total, which first we call the link, call the content of the column. You see, dot link. Link is the name of the column. We have all the links here, and by typing to list, we have the list of all the each items in this link column. So in this way, we can loop over all of the links and get what we want, right? Let's try it. Just say article link. We name it article link. And let's examine the length of the link, see if it's correct. 189. Okay, correct. Oh, I have 189 rows, so not 190, 189. Let's examine what's inside this article. Spend PM, blah, blah, blah. Here. All right. This is a paragraph. Oh, so they put it in, they put each paragraph inside one element of the HTML. This is another paragraph. Okay, cool. And all of the paragraphs until this one. English version by. No. We don't want English version by. This should be the last paragraph that we get, which is in here. So how do we differentiate these two chunk of elements? We don't want this, but we wanted to stop here. So as you may notice, their tags are the same, and their attributes are class, an empty class. So we can't differentiate them only by the tags and the attributes. Okay, but as you remember, as you may notice, there is a link here which directs us to the to all of the articles written by this Susanna Aura person. We can use that, but that's going to cost us that's going to use a very advanced technology. So I don't think we're going to cover that here. So, when you encounter a problem in a production environment and you want to differentiate something like this, like these two elements, and that's going to cost us lots of times only by using a technological solutions. How we differentiate them by using the simpler method. So we can just download them all to our local environment and delete the last element. We can just delete the last element because I believe every article has an element like this. So we can just delete the last element and that'll be fine. We don't have to differentiate these two. We can just delete the last element. Okay. What's this one? Connect may give you away. It doesn't matter. So what we can do is to tell the machine to focus on focus on this section and pull out all of the content, all of the text inside this section, okay? And let's try it. First, we can just connect. No, let's do this. Let's connect to the URL. So URL is the first element of the article link, okay? Let's just try it. We don't have to write the loop, the whole function from start in the beginning. We can just try each step inside the loop, and if each step of the loop is okay, we can put them all into a loop and deploy them into a production scenario, and we get all the results. Let's try the first element. First element, is it correct? Let's try it. There is a space, I believe. So how do we get rid of the space, the extra space in the URL link? We can just do strip bang. Okay, so Yep, this is the website. Okay, cool. First, let's connect to the website that hosts the article and parse the website with soup. Okay, then keep in mind, these HTML might not be the same as the HTML in a computer. So what we do, we export the real, where do I export it? We export the real HTML in the local environment as txt. Open source, that source, not source. Source should be equal to soup.content. Yep. Pretty file. Just do that. Yep. And write source and close. Not a list. What the heck? Soup find soup.prettyfile. Oh yeah, we can just call it prettyfile. Prettyfile. And yep. We have the source.txt. This is the source code for the first article. And let's open it in this editor. Okay. Separate screen. And the tag is div, and the attribute is, actually we can use both attributes or either one of them. I'm going to only use the ID attribute, ctn article body. Let me just search for article body. Here. Okay. All right, let's try it. Say body equals to soup.find all, just fine. Fine. Because there's only one article in it. Okay, so we don't need to use find all. Find we can just first find the first element that meets this criteria. Find a div and the ID equals to a b article body. Okay. And let's see what's inside the body. None type. Body is nothing. Okay, so I think we can only use that. How about we use the, oh, sorry, there's a class. Oh, my fault. Class. Nothing? What the heck? Oh no, this is the body. Yep. Okay, here we are, the body. And let's see the text inside the body, which is the, yep. So in this way, we got all of the content of the first article here. And remember, in the last line, there is a thing called English version by Susanna Ora. Okay, so how we delete it? Class something. Yep. So we can pull out every paragraph by calling that p tag inside this div tag. Okay. So let's just do paragraph equals to body that find all of the paragraphs p. See the length of the paragraph 13. So we have 13 paragraphs, and what we want to get rid of is the last paragraph. So let's see, -1. The -1 means the last. So if you guys remember how to slice a list, it goes like this. So 0 means the first element of the list, and -1 means the last element of the list. So by calling -1 paragraph, we have this English version by Susanna Ora. Right? So we want to get rid of that. So how do we do it? We slice it in a way that only keeps everything but the last element. So do comma -1. This should give us the thing. Let's try see the length of it. 12. Okay. So in this way, we get rid of the last element. And yeah, I'm not gonna go over how to do list slicing. If you don't remember what this means, you can check the first keynote or the first videos, first course recordings. Okay. And let's see, paragraph new equals to paragraph everything but the last element. Let's check it again. Okay, 12, great. And that's the last element. So let's do a list comprehension here. Because paragraph new is basically a mess here. It doesn't give us the paragraph that we really want. We need to call that text to get the words. So how do we do it? We do a list comprehension. Paragraph list equals to I for I dot text for I in paragraph new. Okay, so we don't want last element. And we execute it. And we call maybe the first element. We got the first paragraph, and there's the second paragraph. What's the last paragraph? It stops at he said, ironically, in reference to U.S. President Joe Biden. And here, Joe Biden, not the first line. So in this way, we get rid of the last line using some tricks, but not the technological way. This is really important in the production scenario. When you work for a boss and for a very important project, you need to finish it within a very limited time. You don't want to waste it to develop a fancy mechanism, fancy technological thing to do it in the right way. You want to do it in a timely fashion. So yeah, let's delete it. And so, but how do we put all of the items into one string? Because this is a list, okay? So how do we concatenate each item inside the link, inside the list? Well, we can do it in the old-fashioned way. Say there is we call it test string equals to an empty string, okay? And for each item in the paragraph list, let's do it quick. In the item list, we can just concat them together. Please remember, concat a string, you can't use append to concat a string. How to concat a string? You can just do plus I. That's it. And bang, this is all we need. But you know, that is 3 lines of code. That is a little bit complicated. How to do it in a simple way? So if you want to convert a list to a string, you can just do .join. And the name of the list here, paragraph list. You give it to the same thing. So what does this line of code mean? I put a quotation mark with nothing in it, 2 quotation marks with nothing between them, and .join. That means to join. No, please note this join is not equal to the join with the database. So like to merge or join 2 tables together, that's not that join. Here it means to join each element with this separator here, but we didn't assign any separator, so it basically just join every element without any separators. Or we can put in separators like maybe plus, lots of plus in here, and let's try lots of plus in here. And what do we get? We will get all of the paragraphs separated by lots of plus symbols like this, okay? But we don't actually need them. And remember, we need to store them in a variable. So let's call it the body, new body text, okay? So in this way, we got the body text of the first element from this one to that one. So, but how do we finish this one, finish this process and put them in a new column next to the link? Okay, this entails the technique in the latter half of the second session, which I've posted online in the recordings. So we got 3 minutes left. Let me do it quick. And maybe if you guys can understand, I will explain to you in the next session. Let's define a function here. Call it get body, okay? And put link in it, because we need the link as an input parameter to pull out all of the data in that page. Sorry. Cell is hidden. I don't know why. Okay. Okay, I can delete this one. Delete the source as well. URL. Strip. Don't need that. Article link. Div total. Don't need that. And yeah, this one. Body. Find the body. And delete it. Find the paragraphs. I can just put things and then do a paragraph list. Yeah. And let's do this line of code, concat them together. Okay, let's try it. Okay, let's try it. Let's try if this line of code works. So there's the link, right? Okay, so div total link the to list and first element method is not scriptable. the link and name it as URL. And let's trigger this line of code to see if it gives us the right body text. Yep, right. See, if, for example, for the second article. Yep, this is the second article. You can see what's in the end of it is not something Joe Biden. It's another different thing. So this is the body text of the second article. Oh shit. That doesn't matter. So this line of code gives us what we want, and we can define a function called get body and put link URL in it. Oh, just link and put everything inside it. Don't forget the indentation. Delete it. Okay, this is a function here. What we're gonna do? Return body text. Oh, sorry. Do you guys still have time? Like maybe 3 minutes? Hello?
Yeah.
Oh, cool. If you don't have time, you can just do your work and come back to watch the recordings. Yeah, this is the function, and what we want to do is to put in each element in the link column inside this function, and it will give you the text corresponding to that link. Okay, so what we're gonna do, how do we finish this line? What's on the hood? Basically, the logic is to loop over the columns. So let's loop over the first column. Oh, here's the link. And let's put the link inside the function, and that will give you a result, which is the body, and put the body into a new column called body. Okay, that's for the first line. And loop it over to the second line. Oh, second line, there's the link, and transform the link, put the link through into that function, and that gives us a body, and put the body into the new column of the first line. Okay, and do it over again until it reaches the bottom. Right. So first, let's create a. Let's click that one. Okay. This is the df total, right? 6 columns. Let's add in a new column called body. Equals to maybe blank. Yep. And let's examine it again. Oh no, df total. df total body. So it equals to nothing. Yep. Okay, we got a body column here, and all of the elements inside the body column is empty. Okay, and what we need to do is to put all of the body into this column. And here is the magic happens. df total dot link dot apply lambda x get body x df total dot body equals to this. After we execute this line of code, all of the body will be shown in here. Okay, but it's going to cost a lot of time. So let's truncate the df total to only like 5 rows. Call it df total new. Okay, df total. Say maybe 5. Let's examine the df total. Yep, only 4 rows. And let's try filling the body of those 5 rows. Def total new. Def total new. Great. Trigger get body is not. Oh, need to define it first. Wait for the magic happens. Cool. This is just a caveat. We don't have to worry about it. Let's see the def new again. Bang, body, all in here. Oh no. No, why the link is the same? Get body link. Awesome. Yep. The body's the same. What's happening here? Minister before the commission measure expired. 3. Oh, sorry, something happens. Let's see. Get body X link. Link TFF line. For link. TF total new, TF total new. Body. Lambda X, get body X. Okay. You know what? I'm going to find out the issue behind it, and I will tell you what's happening in the next session. But I will not be here to take up your time further. Let's call it a day. And after I find out the issue, I will send you guys a new version of the keynote, and you can learn about yourself. I know this is a lot because I don't know if you guys have any Python background, but just keep up with it. And we'll talk about how to script the dynamic website in the next session. And in that section, things will get really, really interesting because you can script basically all websites out there. That includes Facebook, Twitter, or just many websites. And we'll talk about how to combat this anti-scripting mechanism, because those websites, these tech giants website, they don't want people to script their content, so they have these fancy anti-scripting mechanisms, and we can sort of in some way to avoid these anti-scripting mechanisms. Okay, all right, so let's stop here and have a great Tuesday. Bye bye, guys.
Thanks, you too.
Thank you.